Hey everybody, I'm James Golick. Just a couple quick things about me before I get started here. I got a blog. I don't usually post talk slides. If I somehow get talked into posting these slides, that's where I'll put them. I have a GitHub account. I released a lot of code. I'm going to talk about some of that code today. That's where it's going to be if you want to find it. I'm also on Twitter. If you want to subscribe to a feed of my shit talking, that's where you would do it. If you want to get in touch with me in general, that's probably the best way. I have email, but I'm generally pretty bad at reading and responding to it. I think I have like 15,000 unread messages in my Gmail inbox. So I'm the CTO of a company called BitLove. We have a couple products, but our main product is FetLife.com, which is the largest social network in the kinky and BDSM communities. Some stats on FetLife, approaching 400 million page views a month. We peak out around 900 web requests per second. Not a huge number, but not a tiny number either. We have, I think, over 1.5 million users. We might be at 1.75 now. We have a couple thousand people signing up every day, so it's definitely growing. Some things that I'm proud of, we have mandatory site-wide SSL. This was kind of a big pain in the ass to implement, but we did it because we thought it was the right thing to do. And we're also profitable, which I guess in this day and age is kind of novel in the technology business. So this talk is really going to be about my experience building, deploying, running, and then ultimately maintaining and kind of operating my first Erlang service. I'm going to go from before we'd even decided to use Erlang up until kind of what the current state of Erlang in our company is. So a little bit about what we were building. Basically, we were trying to expose an IM service kind of on top of our web UI, a little bit like Facebook chat. I don't know if you guys have used that, but it's basically like little IM boxes on the bottom right-hand corner of the screen that just kind of overlay the website's UI. Some requirements that we had, some kind of architectural requirements. Seemed like when we were looking into the options for open source chat servers that most of them kind of expected to be responsible for all of the data and business logic. So things like authentication and buddy lists, they wanted to have their own kind of copy of that data set and be responsible for, like encrypting passwords and verifying passwords on login, stuff like that. We didn't want to have two kind of authoritative source. We didn't want to have two sources of truth for that data. So what we wanted to have was we wanted to have a chat server that was communicating with our main web app via like a REST API or something like that. So that the main web app could be responsible for all that stuff. We also had this kind of hard, I called it security, it's probably more of a privacy requirement, that only users who were friends on the site would be able to chat with each other. Also, it was also important that only users who were friends on the site would be able to subscribe to each other's presence messages. So if I'm not friends with somebody on the site, I shouldn't be able to tell that they're online or send them a message. And it was also really important that that changes in friendship took place immediately in the chat server, were effective immediately in the chat server. So if somebody was bothering me on chat and I unfriend them, they should immediately stop being able to send me messages, which meant that caching that data in the chat service was completely out of the question because we'd be exposing ourselves to latency issues at the very least and consistency issues at the worst. So ended up deciding XMPP looked like a good way of implementing this for a bunch of reasons. Partly because we were hoping to, partly because XMPP is an extensible protocol. I mean, that's kind of the whole point, is that you can extend it. So I knew that there were going to be a variety of kind of weird things that we wanted to do. And I figured XMPP, from my quick look at XMPP, it seemed like it would facilitate that. Also, we were hoping to leverage an existing open source chat server implementation so that we didn't have to implement things like presence and stuff like that ourselves. Also, we're hoping to leverage somebody else's kind of message/conversation history implementation, at least initially. And then the other thing was we were hoping that that we could make use of some of the existing mobile clients for XMPP rather than having to write mobile clients for every platform for our own chat protocol that we invented. If we used XMPP, we figured that people already have XMPP clients for their phones, and there are existing XMPP clients on pretty much every platform. So we figured that we would get to make use of those. Ended up choosing ejabberd because it was From my survey of open source XMPP implementations, it was the best one that wasn't written in Perl. And I kind of have a Perl allergy. If you guys don't know what this is, it's ejabberd is an XMPP server implementation written in Erlang. And since it was written in Erlang and we needed to customize the hell out of it, I had to learn Erlang. So this is kind of where my journey into Erlang started at 3 a.m. one Thursday night. All my Erlang friends were like, "Oh yeah, get the Joe Armstrong book," but that just seemed kind of like a big, like a long project to dive into. So I grabbed the Getting Started PDF off of Erlang.org. I think it's like 50 pages. I think I passed out like right when it finished downloading because it was like 4 a.m. And then the next day I had work to do. It was a Friday. Started getting back into the Erlang stuff probably at about 4 p.m. Finished the PDF at like 8, so it didn't take me very long to get through it. And what was cool was that after I finished reading the PDF, I actually felt pretty comfortable with the Erlang syntax. And I think this is one of the kind of ironies of Erlang is that the syntax seems to turn a lot of people off. People who come from a lot of languages like Ruby or Python or kind of like that class of object-oriented languages seem often to be turned off by the syntax. But really, once you get into the syntax, it's really, really straightforward. It's a really tiny syntax, and it's kind of a what you see is what you get language. The whole issue of balancing punctuation seems like it's going to be really annoying at first, and then after like 3 days of doing Erlang, you just completely forget that it's even a thing. So now that I kind of had a little bit of a handle on Erlang, I started customizing ejabberd. So this was the first Erlang API that, like my first real dive into any actual Erlang code. This API is not the worst API I've ever seen. It's not the best API I've ever seen either. And as my first foray into like actually trying to do something with Erlang, it was kind of hard. In particular, there are some functions in this API that really grind my gears. This is a problem in every language, but I've noticed that it's kind of particularly bad in Erlang, and that is horrible, unnecessary abbreviation. So it took me several hours to figure out what the hell VH was in this context, get_VH registered users. Turns out it stands for vhost. So whatever asshole wrote this code decided that saving 3 characters was so important that they had to make their code incredibly confusing. Fuck you if you do that. Same thing with getPassword_s, stands for getPassword_secure for a total savings of 5 characters. Maybe 15 characters over the whole file. Again, fuck you if you write code like that. Next module that I was customizing is the roster module. So this is the way that essentially you're giving ejabberd a strategy to fetch buddy lists and stuff. Not that much to say about this module, except that I still don't understand why they have functions related to their webadmin interface in the roster module. A little bit confusing, kind of a tangled mess, I think. I just didn't implement those at all. I just left them blank, and pretty much everything else I just copied and pasted, to be honest. So anyway, got that working. The last module that I had to implement for customizing ejabberd was this filter module. And the filter module is the way that ejabberd allows you to insert custom packet filtering logic into their router. So this is the way that I enforce the security policy that I talked about before, where only users who are friends on the site can send and receive messages from each other and presence updates and stuff like that. So this was probably like the first elegant Erlang that I ever saw. Got to kind of get a good look at how kind of elegant Erlang code can be with all the pattern matching stuff. So this is it's a really simple API. It's a function called filter packet. Takes one argument, which is a packet, and if you want to allow the packet to continue flowing through the router, you return the packet, and otherwise you return the atom drop. Very simple, very elegant. This was once I implemented this, I was like, okay, cool. I actually think maybe I do like Erlang. So the next component that I needed to implement was this kind of what I call the IM bridge. The original prototype was actually written in another language, but that language was obviously not suitable for production. It was just something that I did to get something up and running pretty quickly. The current version this version and then all the successive versions have been written in Erlang. Basically what it is it's a bridge between the web and ejabberd. So ejabberd speaks XMPP. There's actually a way of exposing the XMPP stuff directly to the web called Bosh, but it's not actually appropriate for what we were trying to do. So we had to build this kind of piece of infrastructure to sit in between the chat server and the web clients, the browsers. So this thing speaks JSON-P to the web and the XMPP protocol to ejabberd. And it keeps buddy list and conversation state in memory and relays updates to the front end. And the reason that it has to keep all the state in memory is because if a user is browsing around the site and the page is constantly reloading, since the browser is roughly stateless, we have to keep the state on the back end so that every time that the page reloads, we can recreate the state of the IM UI the way it was last page load. So it also turns out that it's 2012 and people like to browse the web in multiple tabs. Our original version of this software, the prototype, only supported one tab at a time, which turned out to be wrong. So we had to figure out a way to multiplex an XMPP session across multiple browser tabs, and then of course to keep those browser tabs synchronized at all times. So if you're in tab 1 and you send a message, sending that message needs to be reflected in all the other tabs so that when you switch tabs, the state is consistent of your conversations. So that was kind of hard, but it turns out that Erlang is a really great way to model something like that because every browser tab can just have its own process, and then the session has its own process, and then there's just kind of like a event broadcasting thing that happens whenever there's an event in the chat. So the prototype of this thing was deployed to 20,000 alpha testers. It was working. We got into production. I think this was probably a month and a half after, or maybe even a month after we started the project that it was like deploying code to production. I'm sure there was there was a lot of bugs, and there was probably a lot of problems with my deployment, but it was working. People were using it, and the system was relatively stable, which was cool. But we were getting a lot of bug reports about presence problems. So people were saying that they were sitting next to someone who was on the site and they had chat, but they weren't appearing as online for that user. So I figured the bug was probably in my code, did a lot of tracing through my code, and then actually decided to just try using another XMPP client that sort of completely bypassed my code, and decided that the bug was actually probably in ejabberd. So I started, so I cloned the ejabberd repository, took a little dive in, and found that it was 60,000 lines of Erlang. I mean, it turns out that most of that code isn't actually the presence implementation, obviously. But when you clone a repository for something that's relatively simple and it's 60,000 lines, it's a little scary sometimes. So scoured the logs. Turns out there's no actual information in the logs that I'm to this day able to make sense of. I don't know why they output the things that they output, but they just don't mean anything to me at all. Turns out that it seems like most of the XMPP server implementation, all the presence stuff, is in one file. It's like 1,300 lines or something. It's called ejabberd_c2s.url. And that file has several functions that span more than 2 screenfuls on my MacBook Air. And if you are a professional programmer and you write functions that are causing me to try to figure out whether I can flip my 27-inch cinema display into portrait mode so that I can read them on one screenful, fuck you. Seriously. It's fucking ridiculous. So at this point, I was like, okay, fuck ejabberd. Started asking myself questions like, what if we wrote our own presence implementation? How hard could it possibly be to write a router? Realized there were a couple of requirements that we missed, like UI state persistence and conversation history persistence. I won't get into those, but it turns out they were important. So wrote the second version, no ejabberd, so we kind of just lost XMPP at that point. I figured if we really need it, at some point I'll just build an XMPP interface on top of my chat implementation. Got it written, deployed, and fully rolled out to all of our users in about a month, which I thought was pretty cool. I said maxing out. I actually meant peaking out around 50,000 sessions with a total of around 200,000 open tabs. Not sharing these numbers because I think that they're particularly big numbers, but just because they are the numbers. I don't think this is the theoretical, this is not the maximum, theoretical maximum of the system or anything. This is just the most that, or approximately the most that we've had connected to it. 10,000 packets flowing through the router per second. Doesn't sound like a lot, but when you consider that every single one of those packets at that time had to make a REST call to our main web app, which was written in Ruby. it starts sounding pretty ugly. Trying to have a Ruby process that processes 10,000 HTTP requests per second and just spits out hello world is kind of a challenge. So one that actually does stuff is even more of a challenge. So that was a problem. And users were exchanging about 20 messages per second, and this was all running on one machine. So some hardware specs, dual Nehalem processors, 12 gigs of memory, dual 100 gig Gen 3 SSDs in RAID 1. The RAID card that we use is really shitty, but it doesn't matter because this app barely does any I/O. CentOS 5.4, that's an ancient version of CentOS. It's legacy reasons, but we're kind of just stuck with it for the time being. And a custom, pretty recent kernel, 2.6.39. So we had some problems. We had to make some optimizations. All those HTTP requests that we were making to our main app were just absolutely destroying us. We added a bunch of machines, but it just was not a good solution. So I had to make the difficult architectural decision of, do we let some random service speak directly to our web apps production database? It's generally not something that I'm comfortable with, but from a practical point of view, it was pretty much the only option here. This is ugly. I would probably make a lot of fun of myself for doing this, but such is life in the real world, I guess. We had a local buddy list cache because some people on our site have like tens of thousands of friends, and so fetching all those buddy lists from the REST API was just way too expensive, and like parsing all the JSON and stuff. So we had to have a cache internally in the service for that, which, as caches do, led to consistency issues and weird latency issues, and it was not good. So we completely removed that now that we were speaking directly to the production database. And we also gutted the router to make it faster, basically, and we were pretty successful doing that. So all these changes spanned about 50 deployments over the course of 3 weeks, and we restarted the chat service process a total of 0 times. So this is pretty cool because I'd always known that hot code reloading was a thing in Erlang, but from a lot of the Erlangers that I talked to, a lot of people seem to suggest that like it was impractical to use, or that they didn't use it because it was too hard, or something. And from the outside, it always kind of seemed like the type of thing that was like, okay, it's there, but does anyone really use it? Probably not. It's probably really impractical to use unless you absolutely need it. Turns out that that's not the case at all. If you use rebar, it's actually really easy to get it set up. And we do continuous deployment on this service. So if you push to the pending branch, the build server, which is Jenkins, builds it, runs the tests. If the tests are successful, merges to master, pushes that branch, and then another project builds, which builds an upgrade package and pushes it to production and runs the hot code swap. So we deploy this stuff constantly without drop connections. And not only do we deploy changes and improvements and stuff, but we're able to like completely gut the internals of the service without ever restarting the process or dropping a connection for no reason. So I thought that was pretty cool. So another thing that I want to talk about is this major bug that we found, because I thought it was kind of interesting how it all went down. Turned out that there were these events that would happen a couple times a day where a whole bunch of sessions would time out at once, like 1,000 or more sessions. Figured they were probably all waiting for something. Seemed obvious, but I didn't have good stack traces from which to determine what they were waiting for. Thought maybe there was a deadlock somewhere in there. But the cool thing was that the whole system appeared completely working through all of this because of supervision. Like tons of internal important processes like the presence agent and the router process were dying. But nevertheless, the system still appeared working to most users. The only way that this bug surfaced at all, the only reason that we even found out about it was because people were reporting like really weird little subtle things where they weren't getting messages, or they were getting messages but delayed. And it turned out that it was because all these processes were dying. So that was pretty cool. So we needed to collect some data. So we're basically catching timeout exceptions from key gen server calls that were throwing exceptions because the processes that they were calling were timing out, and then logging those stack traces. And then I used logger trace files to centralize all that information in one place. I don't know how many of you guys have used logger or know what it is. Okay, a lot of people, but a lot of people not. So I'm going to talk a little bit about logger trace files because it's probably one of the most useful things that I've come across in a really, really long time. So Logger is a logging framework written by Basho guys. I guess it's used in React and some of their other stuff. When you emit a log message in Logger, you can tag it with arbitrary data. So in this case, we're tagging this log message with the Atom user ID and then a user's ID out of a record. And then you can connect to your running Erlang VM and create a trace file. So this trace file says that we're going to put the trace file at var log myservice user-1.debug.log. And we're going to only put log messages that have been tagged with user ID 1 in that trace file. And then we're going to raise the log level to debug in that file specifically. So the big problem with logging on every platform, or usually, is that when something actually goes wrong or when you have a user who's complaining about something, the log level is never quite verbose enough to actually tell you what went wrong. And it's usually impractical because the log level is a global parameter. It's usually impractical to actually get enough log data to learn anything about what broke, even if you are able to repeat the bug. But this allows you to, the logger trace files allow you to elevate the log level just for a specific subset of messages. So I use this like absolutely constantly. If a user says they're having problems with chat, I just make a trace file for them, leave, wait a couple days until tell them to email me next time the bug happens. They email me, I just go look in the trace file and I find out exactly what happened. This is actually like the most useful thing ever. It's really shocking that we don't have this on more platforms. So yeah, you should give that a try. So it turns out that all the dead sessions were waiting on MySQL queries. So as is often the case, I opened up the source code for the MySQL driver that we were using and just immediately started vomiting. I don't know if you guys have looked at this thing, Erlang MySQL driver, but it's fucking gross. And it's also just wrong in a lot of places, like completely incorrect. So it turns out that the MySQL, the connection pool that they built for some reason, only creates one connection by default, unless you specifically call MySQL connect 8. Who writes a function with 8 arguments? Like, that's just bizarre. And I don't understand how they expect you to create a bunch of connections in this pool. Like, where would you put that code? It just doesn't even make any sense. Like, the weird thing about some open source software like this is that you use it and you dig into it and you find the problems and you're like, did anyone ever actually try to start this code? Or like, because if you actually tried to ever use this, wouldn't you immediately realize that it was completely stupid? I don't know. Anyway, so the other weird thing about this connection pool was that instead of failing to return a connection when all the connections were busy, it just sent the request to a busy connection. So turned out there was only one connection in our connection pool. So if one request would take a long time, like one MySQL query would take, whatever, let's say 100 milliseconds, then all the other queries that were happening at the same time would back up behind that, and then you'd have all these sessions timing out. So I forked the MySQL driver to kind of make it a little more OTP-ish, and I ripped out their shitty connection pool implementation in favor of using Poolboy. I don't know if you guys know what Poolboy is, but it's like a resource pool implementation that's kind of popular, I guess, in the Erlang world. And that fixed the bug. So I hot deployed that code, and now the bug is completely gone. So that's cool. So some conclusions. Hot code reloading, that shit actually works. You can use it. You can set up continuous deployment. It's easy. Once you get it set up, you probably won't have to touch it very much. Pretty sweet. Supervision also actually works. It actually, like if you set up your supervisors properly, you actually will have more robust code that will work even in the case of failure. I think that's one of the most powerful things in Erlang is the idea that we're going to accept that buggy and broken code is a reality instead of just completely ignoring it like everybody else does. I actually think that Beam does make operations easier. Things like logger trace files, obviously that's not, you could do that on other platforms, but it's definitely made easier by Beam. Just being able to connect to Beam and ask it questions about what's going on, and to be able to connect to be able to query running processes for their state and figure out what's broken. And especially hot code reloading, because you can deploy like additional logging and stuff without actually interrupting the operation of the service. So that stuff's pretty sweet. But that doesn't mean that all Erlang software is actually easier to operate or even, really possible to operate. One of the really bizarre things that I found when I cracked open the source for Poolboy, which I guess is popular, people are supposedly deploying it to production, was that there's no instrumentation in there at all. So they don't actually have an API for asking a connection pool what its status is, like how many of its resources are utilized. And if you deploy a resource pool to production without instrumentation, then eventually it's going to get exhausted and your shit is going to break. That's just like the law of resource pools. So I just find it kind of interesting that the Erlang world is definitely a lot more concerned with operations and the realities of actually running software in production, but I still think we have kind of a long way to go, at least in the open source kind of branch of it, in terms of having software that's actually easy to operate. The Erlang open source world is a bit of a mess, and actually reminds me a lot of the Ruby open source world. People create projects and they just kind of dump them on their GitHubs or wherever. They don't document them, they don't maintain them, and there's a lot of stuff that's broken. I think of the like 12 dependencies or whatever that we have in our rebar config for the IM service. I think we have like 12 dependencies, and 8 of them are pointing to forks because we've had to fork them and patch them because they were just completely broken or wrong or whatever. But all that said, we have decided that we're going to standardize on Erlang as our kind of primary secondary language, like as our main secondary language. Obviously, there'll be circumstances in which, there may be circumstances in which we have to build a service that Erlang is not a good fit for. But we have a bunch of JVM services right now, and we've decided that as we need to touch them, we're going to rewrite them in Erlang. Most of them are fairly simple and they're stateless, so they're really, really good candidates for Erlang. And it's just that our experience actually running Erlang in production has been so positive that we want more of that and less of everything else. So that's it. Thanks.
How are you finding your other developers on the team are taking up Erlang? Is it something they're teaching, or are they just going out and learning themselves?
I've been the only person writing Erlang so far. I don't know, it's hard for me to imagine people having trouble learning it, because I picked it up just so quickly. But I don't know, I guess we'll have to see when that time comes.
When did you start using Erlang?
So I started working on the IM project like beginning of November or end of October, something like that. And pretty much wrote Erlang every day for 6 months after that, and nothing else. Other questions?
Did you open source you said you rewrote part of at least the routing for the ejabberd piece?
No, that was actually, so at that point we'd ripped out ejabberd completely,
Entirely.
And I just wrote my own router because we have a chat service now that implements all that stuff, implements presence, implements routing. So ultimately I'd like to slap an XMPP interface on top of that and release it as a better Erlang XMPP server, because it's a much better implementation of all that stuff that actually works. XMPP is kind of a nasty protocol to implement.
It's not actually XMPP at this point.
No.
It's sort of more custom.
Exactly, yeah, it's completely custom.
Okay.
It's completely custom. I deliberately structured it internally so that it would be possible to put an XMPP interface on top of it, because that was kind of the plan from the beginning. But I just haven't gotten around to doing it. It's just a horrible protocol to implement. There's so much stupid shit in there. Oh, it's true. What's up?
I used to work at Process One.
Okay.
Totally agree with that.
You know what? I'm going to say this. I didn't say this. I was debating whether I was going to say this. Those guys are not very nice guys. What's up with that?
We've actually forked ejabberd and rewritten a good chunk of it, inserting binaries and rebar files, and making it be compliant and so on.
Oh, interesting.
It's
Okay, so do you guys use ejabberd in production?
Yeah, we usually tend to before they clean up the message we have described right now. And we just ended up, after having rewritten it, I don't know how many times, we just released a lot of changes.
Cool.
It's not feature complete, but it's clean, it's pretty much bug free, and it's efficient.
Awesome. That's cool. I'll check that out. Hey.
In some of the libraries that you've seen, do you think that part of the problem is that people jump into Erlang without really bothering to learn it and learning OTP? And instead of writing it the Erlang way, they just try and write Ruby or Python or whatever they're familiar with in Erlang?
I think that's probably part of the problem. But like the MySQL driver, like some of it was using gen servers. There were bare receive blocks everywhere. There still are in my fork because it was just way too impractical to remove them all in the amount of time that I had to do it. But yeah, I think that's part of the problem, that people just are like, fuck it, I'm just going to write code the way I like to write code. But I think it's also just, I don't know, for some reason I think that there's this weird disconnect. It's like, I kind of like to make fun of object-oriented programmers for being so fussy about their code quality and stuff. And I'm myself very guilty of this at times when I'm writing OO code. And it's kind of funny. Like, it seems like a lot of object-oriented programmers in a lot of languages are way more concerned with how their code reads than whether it actually works. Or they're so concerned with how their code reads that they don't care if it actually works or not. And I think that in a lot of ways the opposite is true in Erlang, or at least for some Erlangers, that it's like if it works, then fine. Who gives a fuck if anyone can read it? So I think that's part of the problem. I think that it pains me to say this, but I think we could actually learn something from like the Ruby community in that way. We could pay a little more attention to code quality and to readability and stuff like that.
Do you use YAWS or Node for handling HTTP requests coming into the web app? Do you use anything like YAWS from Erlang?
Oh no, we use Web Machine.
What testing framework did you use in your CI?
eUnit. It's actually eUnit. It's funny because in the I don't know if you guys know this, but in the Ruby world, like pretty much everyone who writes Ruby code has written at least 3 testing frameworks, and it's completely stupid. But I've actually had this itch to write a testing framework for Erlang, so I think eUnit is kind of a pain in the ass to use, and it could be a lot easier. But I can't bring myself to do it because it just feels wrong. Yo.
You were talking about rewriting other services that might be candidates for Erlang.
Yeah.
So, like, what would you consider a good candidate and what would you consider a bad candidate for Erlang?
So, good candidates, stateless services that don't need, well, really the only bad candidates I would say are services that actually need shared mutable state. I don't think I'd want to write like an LRU cache in Erlang probably. But most other things, unless I can't make my Erlang code performant enough, I would probably use Erlang. I mean, anything stateless for sure. We use Thrift a lot internally. This RPC mechanism that was created at Facebook. That's how we communicate between our Rails web app and our JVM services. The Erlang Thrift bindings are actually by far the nicest Thrift bindings I've seen, so it's pretty promising there.
So your front end is Rails?
Our front end is Rails, yeah.
And you said that you had some issues with trying to get that to handle the level of requests. So you're going through the front end to set up the chat, I guess the initial chat.
Well, so basically we had our Rails processes. We had a bunch of API endpoints, internal API endpoints in our Rails app that the chat server was talking to ask it questions about like people's buddy lists, about authentication, and about routing permission. And the amount of throughput that the chat service was imposing on that API was just too much for it to handle.
And so did you just offload that directly to the database or something?
Yeah, which is a horrible thing to do, but we did it anyway. I mean, it's just not a great practice to have 2 services talking to the same data, like reading and writing to the same database. It's just kind of gross.
Yeah.
I mean, at some point we are going to get bit by that. I'm sure of it, but it hasn't happened yet. So,
Is that more in a security context you're thinking of, or just code syncing with
Yeah, something like that. You know, someone deploys some code to the Rails app that changes that schema, and then chat is broken and nobody knows why, and et cetera, et cetera.
Yeah.
That's going to happen at some point. I'm sure of it.
Have you thought about auto-constructing a view and publishing a description of the view that the Erlang consumes and then uses that, but directly
No,
on the data?
I haven't thought about doing that. That's actually not a bad idea, though. But no, I haven't thought about doing that. I'm just going to wait until it breaks and then I'll fix it.
Okay. That's my strategy too.
You, as part of the testing for the chat server, do you have like a staging level that also for your web app too, so that to avoid that situation that you just thought about?
What do you mean?
Like a staging environment where like, so you have your Rails app, you have your chat server, and everything is deployed in sort of the same at the same time.
Oh yeah, I see what you're saying. No. I mean, in the testing process, all the REST calls were just faked out.
Yeah.
So, and then when it actually gets deployed, it just gets deployed. I mean, there's a million things we could do to lessen the effects of whatever was going to happen. But at the end of the day, like, I feel like when you have two services talking to the same database, at some point you're just going to get bit in the ass by it, no matter how hard you try to avoid it. So, Any more questions? All right, cool. Thanks, guys.